Hi guys, I just wanted to make a quick video that explains how to um, use a graph to find kind of like the slope and the um, quantities to see if things are related in a certain way. On the AP test, they do this a lot. Usually in the experimental design kind of questions, they ask you to plot two quantities. They ask you usually to pick the two quantities that you want to plot so that you can get some value. So I'm just going to start by, um, if we just look at a graph, we know a line, the equation for a line is y equals mx plus b, where b is the y-intercept, y is the y-axis, x is the x-axis, and m is the slope. This is like especially for the AP exam, um, almost always you're going to need to plot something so that you get a straight line. Like it can be diagonal or horizontal, but it's always a line because usually the key is the slope. You're looking for, like, whatever you're trying to look for is the slope, and when you plot two variables on the x-axis and the y-axis, you can find the slope, and that's usually like the answer that you're looking for. So for example, on our one free response problem, it said what two things should you plot so that you can get the acceleration of an object that's rolling down a ramp. So the equation that we came up with from kinematics was that our delta x is equal to 1/2 at squared. And that was from our kinematics equations. And the question was, well, like, all right, what two things are you going to plot so that you get a straight line? And how are you going to analyze that line to get the acceleration? So the key is looking at equations and comparing them to the equation of a line. So if you look at these two equations next to each other, initially they might not look like they have the same format, but they actually kind of do. So I'm just going to show you that by using different colors here. You can see if we plot delta x as our y variable and t squared as our x variable, what you're going to end up getting is this here is our slope. And the y-intercept is technically 0 here. So that's why we don't have that there. So if you look at the graph, or sorry, at the equation, you can see these connections here where this is going to be your y value, this is going to be your x value. So then if you plot t squared on this and delta x over here, you get a straight line, and the slope of that line is going to give you 1/2 of the acceleration. And then that next answer to that problem was, how would you analyze the graph to get the acceleration? You would find the slope of it, and then that slope would be equal then to, so the slope would be equal to 1/2 times the acceleration, and that's how you would get acceleration. This is a common thing in physics. Let me show you another example using an equation that you're not familiar with to show you kind of maybe how you would use this. So let's say you're measuring things and you get an equation that looks like this. Let's just make it a... So here's just a random equation, just letters that you don't even know. The question is, so let's say that we're trying to find what is Q? Like, what is that? What could that possibly be? How would you plot a graph so that you could find what Q is? Well, just do the same thing that we did before. So y is equal to m times x plus b, and then you just make them equal. Oops. So that would be your y, and then our x would be a over d. and then our slope would be, and we don't have a y-intercept, so our slope would be q. So then you would just go ahead and plot a over d on this x-axis and then c on this y-axis, and you get a straight line, and the slope of that line is going to give you q. So that's really like a main idea, and I'll try to bring it up whenever we have physics problems that use this, but for the most part, especially in kinematics right now, you're probably going to have a position versus time squared giving you a straight line. Because remember, if something's accelerating, a position versus time graph is going to look like that. And when you have a curve, you can't get the slope of a curve. At least we can't with algebra. So the only way to get a slope with algebra is if we have a line. And to convert this to a line, we would just make sure we plot t squared, which then would give us that line instead of having it be a curve. All right, so I just wanted to bring that up, and hopefully that helps when you're doing these free response problems.